and get started. And welcome everyone to the Premier SIPS webinar, Pick It Up. Learn how cutting-edge platinum SIPS can improve your design and framing speed, cost, and efficiency. Presented by Todd Bell and brought to you by Premier SIPS. Today's AIA CES registered webinar qualifies for 1 learning unit hour. If you're watching this during the live presentation, we're going to have a link on the screen at the end of Todd's main presentation, and you're going to click that and you're going to be able to provide your information and get an AIA certificate on the spot as well as emailed to you. And if you are watching this course on demand as a recorded session, a 10-question quiz will follow the course and you'll get a link to the certificate at the end. Again, if you have any questions, we take those questions in that bottom pod area and type them in, and we'll come back to the screen, and at the end of the presentation we'll handle those questions. Again, if you're watching this on demand, if you have questions, you can visit premiersips.com. There's a great lots of great resources there, also a contact us area. And also, if you're not an architect but still need continuing education certificate, you can use that same link that we're going to provide at the end of the presentation and enter NA, where it asks for your AIA number. You can then get the exact same certificate and provide it as you need. All right, well, let's go ahead and welcome Todd Bell. Todd Bell is from Premier SIPS and has been in the building products industry for nearly 25 years, training and assisting architects and builders on emerging technologies and projects up to $50 million. For you architects, Todd's a big fan of the modern contemporary design, and when he's not on the job site, you'll catch Todd chasing his 8- and 10-year-olds around the youth sports circuit. All right, Todd, welcome. We've got a great group here, and the floor is yours.
Excellent, excellent. Well, thank you. Well, first off, I'll start off with a small apology for any vernacular that I may abound upon that isn't germane to your particular area. I see some East Coasters here, and I may use a term or two that is more suited for the West Coast area, whereas the East Coasters may be not necessarily familiar with my complete vernacular. So anyways, we'll start off with that. Let's get right into it. Getting past this, okay, we're into topics and learning objectives. Oh, there we go. Okay, so we're going to list the energy efficiency legislation as well as non-regulatory goals, energy efficient for the energy efficient building. You're going to be able to describe what energy efficient building is and the key factors involved with that. Explain the role of structural insulated panels in SIP efficient homes and commercial and institutional buildings. Compare SIP and stick frame construction methods for both design and contractor community. Understand how SIPs are used in the framing process, as well as the difference between SIP insulated options. Discuss design and building applications for SIPs, and last, understand the key steps in working with the SIPs. Alrighty, next. Why are SIP walls, attics, and enclosures? Well, SIPs enclosures increase the energy efficiency by reducing the demand for cooling, heating resources up to 58% over stick frame construction. Now, this is laid out by many different testing facilities, Oak Ridge National Laboratories being one of them. Many state and local authorities do their own separate testing to determine the efficiency of SIPs over stick frame, and for the most part, everybody's come up with somewhere around 50 to 60%, somewhere in there. So, and so what we do is we install 50% average faster than sticks, and ideal when you need your building envelope to perform requirements beyond what solar can do, proposed to 2019 codes. Many homes built to minimum code do not have enough roof area, even working towards zero energy or passive, to even substantiate a solar application. So what I'm trying to say there is that when you design a home, starting off with the energy efficiency allows you the ability to get to that zero energy or that passive home, whereas if you're designing with minimum code and you're building with minimum code, literally there's just not enough roof on your roofs, on your building, to accommodate the amount of solar panels that you would potentially need. Going into energy efficient legislation and goals, one of our first topics here. SIPS enclosures increase energy efficiency and reduce the demand for cooling and heating resources, 58%. Oh, is that doing that again, Scott? Am I clicking? There we go.
I think
nearly half of all U.S. energy is in buildings. Yep. Yeah, I saw it went backwards there. Nearly half of all U.S. energy is used in buildings, and it's expanding, guys. Unfortunately, we are not, on regulation as much as we should be. And what I mean by that is, in a lot of areas, regulation isn't being enforced, and so even with the higher energy codes and the lack of enforcement, we're building buildings again at breakneck speed, and they take up a lot of energy, the heating and cooling costs. So it's over double what we use for energy in an industry, manufacturing and such, as well as transportation. Energy efficient building legislation. California has come out with what's called Title 24. I see many of you, I see quite a few names here that are familiar with some of the Title 24 stuff. New homes are to be net zero by 2020, new commercial buildings by 2030. Now, of course, this is always speculation. I mean, they put this legislation out, and sometimes it's lobbied against because of large companies with deep pockets not necessarily wanting us to travel that fast. We also got behind the 8 ball a little bit with the when we had the downturn in the construction, whereas a lot of the local jurisdictions and codes were a little bit more lax because they wanted to spur the construction industry as opposed to traditionally go push for these higher energy marks at that point. Massachusetts, 40 cities have adopted energy efficiency standards for home and commercial buildings, requiring 20% more than base code. Oregon has more stringent than the 2009 IECC target, a 15% reduction in energy use in new commercial buildings. And AIA's 2030 commitment, we've seen this for about, I think it's been about 10 years it's been out now, calls for long-range stability, sustainability in every project. Carbon neutrality, energy efficiency are key components of that, of course. Aggressive interim targets reaching net zero carbon emissions by 2030. Again, we're all pushing towards this commitment of getting towards energy efficiency. Some states are a little bit more stringent than others, but as a whole, we know that doing things like building additional power plants, whether they're fossil fuel plants, hydroelectric power dams, or nuclear power plants, are not really a goal for the country. Obviously, all three of those potentially take away from our natural resources, which we are limited. Barriers to energy efficiency construction. If regulated and save resources, why aren't more structures energy efficiency? Simply because systems don't address the following. Thermal bridging being a real big one, but number one being air tightness. Here in Washington State, where I'm at and where we manufacture the SIPs, we have a requirement for blower door testing that has been instituted, I think, since 2007, if I remember correctly, and it's been increasing every year. We went from 5.7 air exchanges at 50 pascals down to 5 air exchanges at 50 pascals, and we're increasing every 3 years as the energy code, Washington State Energy Code allows. And we're all working towards that 2030 code, but that's a big part of it. Air tightness is really, in my opinion, the biggest part of it. Moisture flow, proper material and equipment installation, and really that just goes right back to the air tightness. when you use the correct materials and you install them properly, for example, if you're using a stick application, you just have many more pieces of material. Many more pieces of material to move, many more pieces of material to potentially install incorrectly. So minimizing air transfer. The key to construction of an energy efficient enclosure is to, of course, minimize the air transfer, hot to cold, or if you're down south or on the, down in the Gulf or some of that area, or down south in Arizona, such, you may be the opposite scenario. But obviously, what we're trying to do is we're trying to minimize the heat or cooling that you've paid for from transferring to equilibrium or transferring to the exterior or to the interior. There are three ways that heat moves through, and one of them is heat loss culprit is, of course, air transfer. And again, for those reasons that I explained before, with framing you have a lot of components and sealing is just more difficult. Culprit number two is convective looping. So basically this type of heat loss is potentially trapped inside the wall. Once it gets in the wall and it's looping in the wall, eventually because of lack of air tightness, it will escape also. And the third way the heat moves, where we don't want to, they call it the stealth way, of course, here is through thermal bridging. And that's where SIPS bring a big play to the industry. You'll see the top picture where we've got studs at 16 or 24 inches on center, and of course the light color, the yellow color, is representing the heat loss. And so you'll see a stud clearly shown every 16 inches. Of course, 2x material or Douglas fir type wood material has about 1 R per inch, whereas the assembly around it has, if it's a SIP assembly, it has about 4 Rs per inch. If it's a fiberglass assembly, you could be looking at getting R19 or such out of that wall. And of course, it's a lot less than those studs surrounding it. So the thermal bridging has become a big portion of it, and pretty much the second biggest heat loss. SIPS continuous insulation, of course, so going back to that 50% more air tightness equaling the efficiency. Many homes that are, obviously I see a lot of participants that have some familiarity with SIPS. It isn't uncommon for a SIP structure to have a blower door test of less than 1 air exchange per hour, where traditional stick frame applications are 5 to 6 to 7, depending on the time and effort spent to seal around ducts, to seal around bottom plates, top plates, and any lumber that may or may not have shrunk during the construction process. SIP house has fewer joints, less complicated interface between conditioned and unconditioned spaces, and it's dramatically easier to make airtight. This is a statement from Sam Rashkin, one of our Energy Star director. "40 years of in-field testing with HERS rating, well as ICC required air exchanges and leakage. The DOE, through Energy Star, has waived the requirements for blower door test on SIPS structures nationwide. Many of the contractors that utilize SIPS still do blower door testing because they want to prove to the industry and, of course, prove to their clients that they're providing that super efficient home, because in essence that's what they're selling them. But it is not a requirement, and that it is waived for structures because the efficiency is there. From a code standpoint, and this may be different depending on the manufacturer that you're using, but most manufacturers have ICC and NTA approvals and are approved in seismic zones D, E, and F. Depending on where you're at, obviously D, E, and F may not be applicable, but up here in the Northwest, down the West Coast, certainly they are. Beyond energy efficiency, how do SIPs benefit architects and contractors? Some of the benefits that we see on a regular basis are faster installs, of course. Because the panels are manufactured in a factory environment, we cut out windows, doors, cut all the panels to size. Just stands to reason that that the panels are going to be installed faster. You know, we're taking out some of that labor, putting that labor in a factory environment. So when the panels get to site, it's literally just a plug and play, if you will. I don't want to oversimplify it, but when the panels are produced in a factory and they're produced correctly, and what I mean by that is, of course, there is a shop drawing process, and we have to manufacture the product correctly. But when they are produced correctly, the installation time is drastically reduced. What does that mean to all of us? Of course, is that we're not playing catch up after the wet season. Here in the north, again, representing the Northwest, we had one of the rainiest falls, and then of course followed up by the rainiest spring in recordable history. So literally this last week was the first week that we saw more than one day in a row without rainfall. And you know, so a lot of builders are behind. They're behind with their structures because they're constantly trying to tarp, and they're constantly trying to keep things dry. And what SIPs do, of course, is they just speed up that process and allow them to get in the dry and get on to subcontracting and so on and so forth. And or if you're just a SIP installer, it allows you to get to more projects faster. So net result of that, of course, is earlier move-in, sales dates, shorter financing terms, so on and so forth. Tighter structures reduce HVAC requirements. Many structures, and there's some slides about this later, but many structures that are utilizing SIPs are using more high-tech type heating systems. And when I say high-tech, they're just not systems that are difficult. I mean, we're utilizing ductless mini splits. We're utilizing radiant floor heating, as opposed to your traditional forced air systems, which have a lot of ducting, which of course ducting means you're transporting air from one area of the house to the other, traditionally in a crawl space or attic area where this area is not insulated, and therefore you're losing a lot of your heat before your heat actually gets to where you're actually trying to get it to. Extreme design flexibility in seismic zones. And this is just based on the panels being a composite. Because they're a composite and because they have a structural integrity, every SIP panel is in essence a shear wall assembly, and that just allows you the ability to be a little bit more flexible with your seismic design. Less time on the job for laborers obviously means less insurance. L&I insurance here in the Northwest makes up almost a third of the cost of the labor, and so obviously less time on the job site means fewer dollars spent on insurance. Faster and fewer inspections. Factory built, which drastically reduces the job site waste. Many job sites, from a framing standpoint, have 2 or 3 dumpsters of waste removal. Whereas SIPs are prefabricated in a factory, we go ahead and take care of that waste for you, traditionally recycling it within our factory, and we don't ship you the waste. Therefore, you don't have to throw it away. You don't have to pay to throw it away. Reducing callbacks. Large, strong panels with few seams eliminates setting issues common with stick framing. And what we're trying to say there is that it's easier to plumb a wall when it's a large wall assembly, because they're more rigid. You're not having that flexibility that you have with a stud. Well, obviously, with more components, you're having to double check your plumb, double check your squareness more often. Getting into some of the architectural and design benefits. the product can be used in virtually any type 5 construction, residential, commercial, or institutional. For those of you that aren't familiar with what we term type 5 construction, it's wood-based construction. Type 5 construction is based on occupancy and fire rating, of course, and it's wood-based construction. It's traditionally 5 stories or less. There's some square footage qualifications there also. So any type of wood-based type construction we can be used in. Many architectural features are less expensive to build with SIPS. Things like windows and doors that are in irregular places because of the lack of the necessity for headers over all windows and doors. We can plug in openings in different areas. Large spans can eliminate truss requirements. The product has 3 different types of connections, which we'll get into here shortly: spline connection, lumber connection, and an I-joist connection. And each of those 3 connections can span different span ratings, and theoretically up to 24 feet because that's our largest panel, but traditionally 22 feet depending on your snow load. And that'll lessen your requirement for structure underneath it. Structure being beams, gluams, timber trusses, so on and so forth. Support transverse load, wind against walls, gravity loads, loads on roof and floors. Again, because the product's a composite, and because we can integrate lumber at certain areas where we have large window areas and so on and so forth, and we can support some of those transverse loads a little bit better than just a stick frame application. Can be used in interior walls. We do have STC ratings up to and over 50, which can help out with things like common walls, walls in between, in an apartment building between units, that kind of thing, where you're trying to achieve your high STC value as well as get your 1-hour fire rated assembly. Strong, hard to damage. Couple personal applications. We've done a number of native type projects where they tend to be sometimes a little bit harder on structures. Dorms, apartment buildings where maintenance is always a big issue. Well, you see somebody walking around the apartment complex with a broken hand after a rough night, and most likely they've hit a SIP wall instead of a stick frame wall where your hand would go through it. With a SIP wall, of course, you've got plywood right behind it, or OSB right behind it, so you have a full structure right behind it. Sounds a little humorous, but
that's a whole new sales pitch there for you, Todd.
Well, you'd be surprised. You'd be surprised of the damage that can get done to dorms, apartments, some of the native housing scenarios. I mean, I've personally sold projects into native housing just for the maintenance factor alone. Certainly the installation value and speed of construction are important, but if you're spending half your time fixing sheetrock problems and so on and so forth, SIPS can save you there. Great straight and flat surfaces for interior finishes. One of the things I always note with that application is simple application of gypsum. Normally when you go look in a dumpster at a job site, a framed wall job site, anything under 16 inches wide gets thrown in the dumpster from a gypsum or sheetrock application. Whereas with SIPS, of course, you're sheeted on both sides continuous, so the use of those smaller pieces of material from a sheetrock standpoint they're used. I mean, they're just not thrown away. SIPS meet the continuous insulation requirement of the 2012 Energy Code, so no extra steps needed, and I think we'll go into that here shortly. Beyond benefits, what are the SIPS? And I know it's kind of a little bit backwards. We wanted to go through some of the performance aspects of the SIPS before we really got into what a SIP is about. The SIPS are a high-performance engineered component for walls, roof, and floor. Essentially, we're just working on the envelope. We're working on the insulated envelope. We've got outer skins. Traditionally, those are OSB. And why? Because we can get large pieces up to 8 by 24 in size. And then the foam core is a rigid foam core, EPS, or the new graphite enhanced GPS. And again, we'll get into the GPS here shortly. Again, available in sizes up to 8 by 24. When we're talking about larger pieces, as you see in the picture represented, that can, again, drastically reduce your construction time. Standard shapes, sizes, or cut dimensions available. When you talk about some custom shapes like radiuses, windows that have arch tops, that kind of thing, in a factory environment where we use a CNC router, those actually become pretty straightforward. In a stick frame application, those are hours on end getting those to install. Normal core thicknesses from 4 to 12 inches. Those are your nominal. The core thicknesses always match up with your dimensional lumber thickness. So when we say core thickness 4 inches, we're truly meaning 3.5 inches, same as a 2x4. When we're saying 12 inch, we're meaning 11 1/4, same as a 2x12. Available in EPS or higher R value GPS insulation core. Serve as a turnkey structural and insulated high performance framing system. What we're saying there, of course, is that there's not multiple systems coming together. System meaning structural system, i.e. a stick frame system, and then adding in an insulated system. When you install this product, it's the 2-in-1. It's all in one system. It's also an air barrier. Replaces exterior walls, floors, and roofs. Again, up to 58% more efficient. I think we said that 3 or 4 times, trying to really drill that part in. Proven system in the field for over 40 years. That pretty much represents what we, as a company, have put into the industry, about 40 years. Going back in time, SIP panels were actually originally started in the 40s, so they've got a much longer history. Warranted, unlike other framing options. Most manufacturers offer a warranty for their lamination as well as a warranty for their R value, whereas you traditionally don't get that with other building components. Manufactured in factories for engineered efficiency. Large panels with factory engineered accuracy eliminate variations found in conventional. And again, that was explained earlier about the straight plumb walls. Incorporated air barrier. So this slide really talks about what you would need to do to take a framed wall and get it up to the performance level that you would have out of a SIP panel. On the left there, you'll see 7 steps. So you stick frame a wall, you insulate that wall cavity, and then to get that R value up to what you'd find in a SIP structure, you'd have to add some sort of continuous insulation. A lot of code areas require an R5 continuous insulation on the outside of the structure. And then you'd have to, of course, fur or side that out and have your weather-resistant barrier on there. Whereas SIPs, of course, have the high insulation to begin with. They're sheeted on both sides, so you've got your SIP, your weather-resistant barrier, and straight to your siding. Advanced framing options. Previous option, of course, 2x6 framing for roof and walls. You've got your standard EPS insulation core, and then we're going to your platinum, and this is when we're going to get into talking a little bit more about your platinum. 20% better R value over minimum average. So platinum SIPS. So what we've done is we're expanding it. The expansion process is exactly the same as with expanded polystyrene white foam, as you may all call it, or beadboard. Except the GPS has it comes to us pre-coated with graphite. Graphite has a reflectivity that gives it a higher R value. Because it's the same process, and the actual labor for us to manufacture it isn't really any different than your standard EPS, and we can achieve a 20% better R value, basically going from 4.17 per inch to 5.1 per inch. The cost is actually pretty low. So you're in 6 to 7% more cost for the increased cost of the material. Again, no increase in labor from our standpoint, and you're achieving about a 20% better R value. This also allows you the benefits of, in a roof application or even in a wall application, of going with a thinner panel. A lot of local code jurisdictions, at least in the Northwest, require an R38 for vaulted cathedral ceilings. Traditionally, that would push us right towards a 10-inch SIP panel in an EPS variety, whereas with the GPS that we've now incorporated into the system, we can step back to an 8-inch panel. This, of course, would save on pieces going down the road, because we can get more pieces on a truck. We can have less trucking. It'll also save on things like perimeter subfascias and some of the lumber that gets incorporated into the product. From an architectural standpoint, a thinner eave line is more, doesn't weigh down the building, doesn't make the building look heavier, as opposed to there's lots of details out there that we utilize to try to make a 12-inch roof or a 10-inch roof assembly not look like a 12-inch roof or a 10-inch roof assembly, because it makes the building look potentially heavy from a roof standpoint. Whereas going with a thinner panel, you've got that taken care of. So again, this is talking about the platinum in comparison to comparison to your standard EPS. Your 6-inch wall, where traditionally you're in somewhere in the 23.8 range to 24 range, will net you 27.5. Because it is an assembly, you can look at your interior gypsum and your exterior siding as part of that assembly, depending on whether you provide in an airspace or not. And then as you go up into the 8-inch, 10-inch, and 12-inch, this 8-inch, as I stated before, can be utilized as a full assembly to get up to that R38, thus achieving a code requirement with an 8-inch panel. The colder it gets, because we've encapsulated air into that foam, the colder it gets, of course, the more dense the ambient air gets, and the difference between the encapsulated air and the ambient air gets, and you'll get a higher R value. So the colder it gets, the better it actually works. We're going up to down to 25 degrees here. Some of you in the Midwest may actually get down to 0 or minus degrees, and again, we've got some charts that show R value at 0, R value at minus 10, all the way up to, believe it or not, minus 100. But the point is that as it gets colder, the insulation and the R value works better. The insulation, the value goes up. With conventional framing, every opening has a header of some type, going from 2 2x4s to 2 2x8s. With SIPS, most of the headers don't need, or most of the openings don't need headers. Specifically, if you're 4 foot or less on a window or door opening, depending on the load, of course, that's on top of that window or door opening. There's a lot of creative ways to span across windows and or doors in a SIP panel application through floor system, rim joists, and things like that, allowing us again to provide larger panels to install faster. It also means that you don't have less of an R value or in that header area. Traditional 2x4 to 2x8 box beam style headers, of course, integrate lumber into the system, which decreases your overall thermal resistance at that area. We talked about this a little earlier, some of the warranted advantages, with framing and some of the other products that you may find out in the industry. They may have warranties, they may not. Framing, of course, does not. Our state in particular only gives a 1-year homeowner's warranty, so after a year you're kind of on your own. Whereas we provide a 20-year warranty on lamination and a 20-year warranty on R value. And as you look around to some of the different manufacturers in the industry of SIP panels, most all of them will provide some sort of warranty for you. In the field, again, slow start to the year. Large volume SIPs install faster and help you stay on track. Faster install, no studs to find, less laborers needed. Just thinking about trips back and forth to the lumber pile, you can obviously think about how SIPs are going to install faster. You're looking up at this picture and the top picture as well as the roof install picture. When we have the ability to manufacture a panel as large as 8x24, that's basically 192 square foot of wall assembly or 192 square foot of roof assembly that can be installed all at one time. And that's going to just drastically reduce your installation time. Less trimming means less mess. Again, we're manufacturing in a factory environment. We don't intend on sending you any cuts to make, so less cutting, just means less cleanup. Simple things of cleanup at the end of the day. You have a lot less material to pick up because, of course, the waste isn't there. Factory cut edges for accuracy and square edges. We have many of the companies that manufacture SIPs have very strict Q&A programs, which means that when the product gets out to the site, you're not dealing with some of the twisted, cupped, curled, bowed, tweaked scenarios that you do with frame construction. Factory go down to every screw grabs, so obviously no chance of missing a stud because you're not actually trying to attach to a stud. Large panels, simple assembly, removing much more of liability from the other framing methods. Again, more pieces means more potential for movement of that product. As you have movement, you have things like air loss, you have nail pops, you have all those things that coincide with a structure moving after it's been constructed. This just talks about what we're used to in regards to installation. Typical 5-person crew. You may have more or less people than that, but 2 people truly installing the panels, setting the panels, 2 people preparing the next panels for the installation, preparing it, and what we mean by that is possibly presetting the screws, putting the lumber in around window and door openings, installing a spline at a connection point, and incorporating the mastic that it's utilized at joints to create a good seal at those joints, and you have it. So smaller crew, faster install. Manufacturers provide shop drawings showing every panel. So this is where we really get into the simplicity of the product. A lot of the pre-thought that traditionally doesn't go into stick frame applications. A lot of times, not to get on a contractor or framer, but you bid a job, and once you've got that job, it may be a couple, 2-3 months in the permit process. You have a foundation to get in and all your subs to get in there prior to setting the panels. So where do the plans go during that time frame? Well, they go behind your truck seat, and you pull them out 3 or 4 or 5 days prior to the building the structure. You order up your lumber pack, and it gets drop shipped off. So not a lot of time is taken in the pre-thought, where with SIPS it's kind of a necessity. We go through a shop drawing process. During that process, we're locating windows and doors. We're reviewing things like electrical. We're reviewing things like plumbing, because of course we want to make sure that we don't create any pitfalls in the future. And what that really does is it just allows us to get a better grasp on what we're getting into. So through that shop drawing process, we just do a better job up front. Once those shop drawings are approved, the manufacturer fabricates the panels, cuts windows, doors, width, height, everything specific to your project. They pre-label every one of the panels with a number that corresponds to the shop drawings provided, and basically it's just a Lincoln log set at that point. A lot of the pre-thought, of course, is already done. So W is a wall and R is a roof, and the corresponding number goes in the corresponding place according to the shop drawings. A short little video showing some of the different panels as they're going in. Because these walls are over 8 foot tall, let's say this is a 9-foot wall or a 10-foot wall from a height standpoint, you'll notice that most all those walls were 8 foot wide. Once you get to 8 foot tall panels, then we can turn the panel horizontally and go up to a 24 foot long wall. Faster installation, again, I think that's the 4th time we've mentioned that, but reduced mechanical, slide panels into locations easily, tilt walls together, they drop right into place. Plumb and level at corners, whereas with framing you have to plumb and level throughout that wall. Traditionally with SIPS, if you plumb and level at the corner, it makes it extremely easy to plumb and level as you go, and you have to plumb and level a lot less frequent. Now getting into the SIP roofs, we've established that we've got a wall. You'll notice that those walls have changed from a plate line type wall where a truss scenario would go on top. Now we've got gable walls running full height and a ridge beam running across. And while this is a very straightforward, simple ridge scenario, hips, valleys, shed dormers, all those kind of things are not difficult, because again, part of the shop drawing process is to accurately depict those in those shop drawings and then cut those in the factory. So doing more difficult roofs is very straightforward for us also. Use rigging on the first couple panels only. It's going to save you money. Depending on the size of the panels you're using, most all SIP installations for a roof are going to use mechanized type equipment. Of course, anytime you're working above your head, the less frequently you have to work above your head, the better. So a lot of times we see as large of panels as possible. In both the pictures you see there, you'll see a snorkel boom and an actual boom truck setting panels, and if we can facilitate 8x24s on your roof assembly, again, we're installing 192 square foot of that roof at one single point. Slide panels into locations instead of carrying. This is just kind of a housekeeping type means and methods scenario. Some people use furniture dollies to move them across your floor system to get them to your place, because they are larger sizes. Obviously you don't want to. That's one of the very few negatives, is that they can become cumbersome if you get them too large. So know your ability, know your site, know your accessibility for mechanized equipment before you choose an actual panel size, so that you make sure that you're working with the size that works best for you. We can certainly manufacture panels smaller, down to 4x materials, to accommodate your job site. Double nail the top if you can't get to the underside. What that's trying to tell you is that when you're installing a SIP, a lot of times applications are where joints are at the bearing points, and if a joint's at a bearing point, you're going to just double nail the top. You don't have to get underneath and nail the bottom at that bearing point. Again, up to 20-foot spans. Theoretically, you can go up to 24-foot spans. From a conservative aspect, in a 40 to 50 pound snow load with your total load combination, 20-foot spans are completely doable. As you increase in snow loads or roof loads, you will decrease those spans. Again, there's 3 different ways that the panels can connect. We talk about the spline connection, the I-joist, and the lumbar connection, and those 3 connections have different capacities for their allowance to span. Proven structural capacities result in the option to eliminate trusses or cathedral ceiling, for cathedral ceilings. Many projects that we do, whether they're contemporary or truss or beam applications like you see in the pictures represented, the panels are either spanning from ridge to eave, or they're spanning left to right. Either way, they're in a span condition that allows for big open vaulted cathedral areas. Again, because there's fewer pieces, comparing SIPS to a rafter type detail where you've got a fair amount of potential shrinkage in those rafters, because they're larger 2x10, 2x12, 2x14 pieces. When they go from their again traditional 20 to 24% moisture content down to their functional moisture content, which is somewhere between 7 and 9%. That's a great amount of shrinkage. When you have that shrinkage, you have things like drywall sag, nail pops, those kind of things, which of course are callbacks, are where your contractor or somebody's got to go and fix those issues. Panels attached together, we talked about splines. Show you a picture. So typical spline connection is just a thinner panel in essence. It goes half in one panel, half in the other. You install it into one panel, making that panel a male panel, and then slide the next panel over it. Both of those panels encompass half the spline. You nail through that spline with an 8-penny nail, connecting those 2 panels together, and that's in essence how you connect one panel to the next panel in the field. At a quarter connection, we utilize screws. Those screws are put in at approximately 2 foot on center, more frequently if engineers required. But those screws go through the panel that runs long into the lumbar of the panel that runs short, as depicted in the picture. Again, we eliminate bridging of lumbar. Lumbar at a connection is a thermal bridge, so that's what the spline is beneficial over a stick frame type connection. Splines don't expand, contract with seasonal temperatures. Of course, you want to keep the product dry during the installation aspect of it, but there's a lot less movement from an expansion contraction standpoint because there's actually less lumber to do that, or less wood material. We're going to move into a couple of just different applications and case studies. We've got here a 1,900 square foot assembly.
Nope, you're fine, Todd. I'm going to let you talk about it real quick while I hit play. Okay. So what is this, Todd?
So this is just a very simple rambler home. We're representing wall and roof application. It's a time-lapse install.
And if you're having a hard time, we're just doing a quick 2-minute video here while Todd talks through it. If it's you have a little bit of a slow internet speed, it might delay, but we'll let it play through, and then if you want to catch it again, we'll have it available on demand. Todd, how long would a normal house like this framing take if it wasn't being done in SIPS?
Well, you know, again, depending on the experience of the contractor, you know, you could probably look at a week to 2 weeks on a framing scenario. If you've got a really good framer, you know, they may be able to install this as quick as a week. With SIPS, this is a one-day process. The panels are already pre-cut. They're already ready to assemble. They're already pre-numbered. And the installation just
one day you can certainly get
goes a lot quicker,
much faster that way. That's for sure. So Todd, we've got we'll let this continue to run because it's fun to see the house completed as things go through. We've got about 7 to 10 minutes here left on the time and whatnot. So we'll try and pick through up. I'll ask this question real quick while we're playing this. Long ask, what's the typical weight of the panels?
Well, we're running about 4 pounds per square foot. So in 192 square feet, you're ranging right at about 800 pounds, somewhere between 750 and 800. Again, the installation of a wall or a roof assembly, if you get into those larger pieces, is going to require some sort of mechanized equipment. If you get over, let's say 8 by 12, you know, you're getting into the 200, 250 pound range. But anything less than that can certainly be installed by hand.
All right. Well, we've ran through the video, and Todd, if you just want to kind of cruise through the rest, like I said, we've got about 5 minutes left, and you guys can type in your questions there, and we will we'll catch those at the end. So
we'll go through a couple of these. We'll go through these options really quickly because we are getting close to time. And then we'll get into these case studies. Some additional SIP options. So these are some really exciting options that have kind of new to the industry and help get over some of the challenges that are that were previously challenged with SIPs. We now offer, and many manufacturers offer, a product called Zinc Borate OSB. So this OSB has a zinc borate coating, and it's actually infused into it as well as into the OSB, which greatly decreases its ability to take on water, greatly decreases its ability to decay through some of the rainy season install applications. Factory installed lumber, even to speed that process up even more. There are quite a few manufacturers that install 2x material around windows, doors, and connections where needed. And then, of course, the platinum insulation over the standard insulation. Some of the simple thoughts again, and I've covered most of these. because walls install more plumb, things like trim, cabinet work, that kind of thing, just install easier, more plumb. Because of the tighter construction, things like the ductless mini split, and over an HVAC system where it moves air, it's required to move more air because your home is obviously more leaky, more drafty, more air exchanges. Whereas with less air exchanges becomes the ability to control your inside air quality and heat movement more efficiently. Ductless mini splits one great way to do that. There's the ability to decrease if you do have a forced air system, and or even if you're using a ductless mini split or some other type of heating system, you can decrease the size of those units. Plumbing is not typically put into SIP wall applications. Certainly there's through penetrations, hose bibs, stuff like that, but a lot of the hot and cold water supply is brought up through your back of your cabinet area. Electrical, there's electrical chases pre-installed in the SIP panels at your standard plug-in and light switch heights, as well as wherever we need to based on those shop drawings. Now we're getting into these case studies. SIPs install faster. We've talked about that 4 or 5 times. Means states that it's about 55% faster installation. Of course, that depends on the design and simplicity of the structure. Here's some case studies. Clarum Homes in Menlo Park, California. Just getting a home to zero energy or passive when you're starting off with essentially a good core or a good structure is a necessity. This particular building, if framed, would have required solar panels on every darn stitch of roof that you can see available, including the garage. Because it was a SIP panel structure and because it was efficient to begin with, you can see a small section of solar panels on that upper roof.
Case studies in here, but we've got some good questions. We're almost at the top of the hour. If it's okay with you, let's go to the wrap-up. We'll put up the certificate, and then if there's still time, if there's still some interest, we can hit the rest of these case studies, unless there's one specific that you'd like to hit.
Well, the first one says, are there case studies available?
So while you look at
those,
on it. Yeah.
Are there case studies?
Yeah, because we'll talk about the case studies and the cost and whatnot. Let me get the certificate up, and yeah, there's actually some really good questions back here, so we'll hit those in a minute. All right, guys. So this we'll end this as our official end of the AIA certification part of it all. We've got some great content. We've got a little bit of Q&A still to go in here. So let's talk about how to get the certificate. If you're participating in this live webinar, we've got the certificate here on the screen. Either way, even if you're listening to it as a recording, right in the button where it says AIA or Participation Certificate, if you click where it says click here and then click Browse to, that's going to open up an area where you're going to provide your information. If you have your AIA number, click in that. A certificate is going to be emailed to you, as well as on that landing page. You're just going to be able to click it, download it. It's already personalized. It's got the number on there. If you need it for regular education purposes, if non-AIA, just hit NA. Same process. You're going to get your certificate right there, and then we'll report it to the AIA. So Todd, we do have some really good questions in here. I will let you hit those, and then we'll wrap it up.
Yeah, there are some good questions here. So the first one actually asks about some case studies comparing stick frame construction against SIPs in a cost comparison. Of course, what we have to first consider, of course, is that we're not building minimum code. Traditionally, when you talk about stick frame construction, you're talking about minimum code. So it's difficult to compare something that is minimum code comparing to something that is in excess of minimum code by some 50%. But there are some case studies out there. We have some case studies on our website where basically the product material, which you are correct, the product and material is traditionally 10 to 20% more for the material, and that's basically because we're taking a fair whack of the labor out and we're incorporating it into the factory portion of the scenario. So as a whole, the day you get the panels are 10 to 20% more. Now there's a labor savings on site, and of course if you save the hundreds of man hours that are traditionally used in framing construction, you could potentially save that back. If not, if you don't save that back, and let's say maybe there's a break even or you're spending 5% more for the material, the traditional payback for Department of Energy is down to less than 2 years. So what we're saying there is that even if you net let's say 5% more for the material at the end of the construction cycle, the move-in cycle, after all those different savings, you're going to represent to your customer a payback of less than 2 years. And then of course every year after that 2 years they're going to be into a net gain. Let's look at the next question here. Can you use SIPS on a curved wall? There are some manufacturers out there that incorporate SIPS with a curved wall assembly. The way that Premier manufactures the SIPS, they cannot be used in a curved wall very easily. And what I mean by that is the way that most manufacturers press, they use a flat press. And so curving the panels means that you need to make a mold, and making a mold is traditionally expensive. So while they can be done, the expense traditionally dictates that they're not. Curious how platinum graphite SIPs compare otherwise with standard SIPs, either per inch or per R value. I think I talked about that a little bit during the presentation. So they rate out at about 20% more efficiency. At 20 degrees you can get, or let's just go at 75 degrees. At 75 degrees mean temperature, you can get about a R3.8 with a standard EPS foam. You can get about 4.6 with GPS foam. So it's about a 20% better value. Going down to 20 degrees, you're at 4.17 and then up to 5.1 R value. So you're netting out about 20% better R value. And that in comparison to cost, you are at a 6 to 8% more cost. So 20% better R value, 8% more cost. Kind of a no-brainer if you're going with SIPs to begin with. Can you run fire sprinklers in SIPs? Yes, there are a number of details that allow us to run sprinklers through SIPs. Of course, it would depend on how complex that SIP system is, as well as how complex the sprinkler system is, and that just depends on how many legs there are on the sprinkler system, and how that's designed. But yes, there are a number of details on sprinkler systems in a SIP system. We are looking for large-scale production of 2 for 3-story apartments in the U.S. abroad. We're in favor of SIP. We need SIP panels and installers. We have our plans and our units are pre-sealed. How do we go about finding SIPs with all options and installers? Well, first of all, you obviously got to look at who is going to be your local manufacturer. Of course, if you're on the west coast, I mean, you stayed abroad, so I'm assuming that you're in many U.S. cities. So there may be applications to to work with us, and then there may be other applications where it may make more sense to work with another manufacturer. Let's say if you're up in the New England states. As far as manufacturers, installers, most all salespeople in particular sales areas have lists of installers that they can recommend to you that will either traveling SIP installation crews or SIP installation / framing crews that will install the whole shell of the structure. So I would just get a hold of your local representative, and they will get you a list of different installers, and then you can go from there and contact them. What happened to the Dixon plant? Well, we got pushed out of the Dixon plant, basically. It's a good thing and a bad thing all at once. Our foam facility recently acquired another foam facility in the local area, almost doubling the capacity of what we need to manufacture from a foam standpoint in Dixon. That facility became awful small when you're manufacturing now twice the amount of capacity for EPS. And so it made sense to manufacture the panels out of our facility and subsidize some of the freight down into the areas where Dixon was handling before.
Well, I was going to just remind everybody, and Todd,
we have any?
Catch
Go
it.
ahead.
There's a few more good ones in here. Second floor framing, really interesting questions and whatnot. Remind the folks still on the line here, if you haven't already, to get your AIA or participation certificate, just click in the middle box there where it says click here, and then you click the Browse To button. That's going to open up a new screen, new browser. That's where you're going to provide your information and get your certificate, participation. And again, if you're listening to this on demand and you haven't gotten to that point yet, you're going to have to take a little 10-question quiz to get your certificate, just to confirm that you have actually participated. So, all right, Todd, what else have we got here, man?
So the next question just talks about some case studies for low-income housing utilizing SIPs. As far as case studies through HUD and through some of the other jurisdictional things like some of the native housing and stuff like that. Certainly, there are a number of studies out there. Basically, it really depends on who's paying the heating bill. Certainly you can build a house less expensive. If you're following minimum code. Some of the benefits for low-income housing are what we talked about before. Maintenance tends to be really high in low-income housing, whereas the maintenance can be drastically reduced by utilizing SIPs, just because of the nature of the lack of movement, the structural strength of the product, and the sheathing on both sides of those exterior walls. But what I mean by paying the who's paying the heating bill, because at the end of the day, once that house is built, really the only thing that is to be dealt with are heating, cooling costs, and then of course maintenance. That part of it becomes a really big part of the overall operating cost. And so from a sales strategy to those low-income housing, HUD, that kind of thing, our strategy has really been about maintenance and operating costs, because with a payback of less than 2 years, it just makes sense to use SIPs in that type of application. Some of our case studies are really big applications, 200, 300 unit apartment complex like the Saran Knight that you're flipping through. If you can flip back to that case study. So feel free to get a hold of your local salesperson. We can send you some specific stuff on those case studies. How much of a decrease in load with horizontal versus vertical installed panel size since using OSB skins? That question is an interesting question. Most of our testing is done with OSB. As a matter of fact, very, very little testing is done with a different type of skin, such as or plywood or something to that effect. So to give you a percentage of a decrease in structural integrity is difficult. The primary reason, of course, for utilizing OSB skins is the sheer ability to manufacture larger pieces. Because we can utilize larger pieces, the product is more it's the larger pieces mean less joints. When you go to plywood or some other type of skins which are more commodity style driven sizes, meaning 4x8, you just have a lot more pieces. Then you have a lot more ductility between those pieces. So kind of a difficult question to answer because there's not a lot of testing on some of the comparing some of the different skins. How is the second floor framed with SIP walls? Well, there's two different ways that that we frame here in the States, and one of them is standard platform construction, where you build a wall, you set your floor system on top of that wall, and then you build your second floor wall. An interesting way that you can build with SIPS is to balloon frame. So what that means, of course, is building a wall 2 stories high. So in essence, instead of having a 9-foot first floor and an 8-foot second floor, you have an 18-foot tall wall, and you hang your floor system from the SIP panel in a ledger type application. So 2 different ways that they can be done: either platform framing, where you attach directly to the top plate of the wall with a traditional TGI or floor joist and rim system, or
Good.
you
Hey Todd,
can
you okay
do
on time?
a
We still have a few questions coming in. All right, guys. Well, there's still actually real quick. There's still a few folks, quite a few people left in the room. So if you've still got questions, feel free to type them in, and Todd and I will just hang out and answer questions for a little while.
I feel like when I give presentations in an open room, I feel like the Q&A part is basically the best part of the whole thing. So I'm all for answering as many of these as come in. Can we utilize continuous insulation in ComCheck and ResCheck in lieu of cavity insulation? That's a good question that honestly I don't. It sounds like we're maybe a ResNet or a energy verifier type question, and I'm not 100% sure. Certainly there are some applications within the ResNet stuff that allows for SIP panels. That's a good question, and maybe that's one I'll write down and get back to you, Jim. I think my email address is there, and I can look into that one and find out how the
Jim, if
verification
you want
system works for
Todd
that.
to drop you a quick response there, if you want to just put your email address in the Q&A pod, we'll follow up with you.
Can panels ever come longer than 24 foot in length? There are a couple manufacturers, predominantly in the Midwest and down in the South, of OSB that manufacture it longer than 24 foot. I would like to say that 75 to 80% of the manufacturers are working with 24 foot max as their max length, but I have seen some 28 foot board come out of a few manufacturers. So that would be a good question for whoever your local manufacturer is. If it's us, of course, then 24 foot is our maximum length. Plumbing pre-design considered? When we look at a floor plan, you'll always look at the plumbing and determine where there's either a potential interference or whether you have to create a solution. The only thing that we traditionally worry about in an application are vent pipe applications. Your cold and hot water supply, can come up in the back of the cabinet area. If you were to have a pedestal sink, certainly we could go through the wall to stub out for a cold and hot water supply in that applications. But most, and I don't know where you are, Anthony, but most applications like to take place on the inside surface of the wall, protecting the plumbing from any potential freeze scenarios. But in regards to venting, we can create a vent chase in the panels, which allows for your 2-inch vent pipe to go up to the second floor system or into the attic area or to an area where you can connect with other vent pipes from other toilet and sinks to join together and run out of the roof with a few penetrations. How are SIP walls used in renovation projects? Has anyone used them to seismic upgrades? The seismic upgrade is an interesting question. So I'll answer the other one first. In a renovation project, certainly we've done a ton of additions with SIPs, and let me give you the reason for that. Obviously, when you have an existing structure, you also have an existing heating system. Most of the times when small additions are made, upgrades to heating systems are not made at the same time, meaning that you may want to add a 400 or 500 square foot great room, or you want to add an extra bedroom, or you want to add an addition to the home. Most people don't want to, in addition to that, spend the extra $6,000, $7,000, $8,000 to upgrade the heating system to a heating system that will accommodate the additional square footage that you've added. So they utilize SIPs, and SIPs, because you can add that square footage and it's so virtually airtight, it's like adding a lot less square footage, so you don't have to upgrade that heating system. Certainly that heating system is going to take on a little bit more of a load, but utilizing something that is extremely energy efficient helps you not have to take that extra hit with upgrading your heating system also. The second thing, have they been used in seismic upgrades? Certainly SIPs have resistance to seismic, both in a transverse load laterally. If you were to utilize those on something existing to upgrade, I don't know how that attachment mechanism would work, but certainly it's a thought. It's something that could be done. Traditionally, they're used as a replacement and or an addition, like you stated before, not necessarily as adding to something that's already existing, if that makes sense. Clarification on my question: what is the decrease in load capacity of panels when laying an 8x24 panel on its side versus standing vertically? The OSB, it's only actually about 10% less capacity. So the OSB, and what Rick is referring to is that OSB has a strength axis. There's actually arrows on the OSB that essentially dictate the strength axis of the material. When you lay a panel, let's say from a vertical application to a horizontal application, the strength axis of that material is decreased. Most all of our testing that has been done has looked at it both ways, because when we take and we laminate that into a composite, it takes that what is traditionally a 30% decrease in structural integrity in just the OSB alone and decreases that through that lamination process. But there definitely is a little bit of a decrease in capacity, but it's pretty minimal. And that's taken into consideration during the engineering process. Are the lateral engineering details like hold downs, heavy point loads for beams done by the project engineer or the manufacturer? Carl, that's kind of both. The loads, we've done this for enough years, we kind of have a very good idea of what the engineers are going to put out there in regards to when they're going to dictate, let's say, a post go underneath a beam, or whether a beam can just sit into a pocket created into that panel, or whether a panel needs a hold down at a particular place based on the size of the opening or the lack of lateral resistance in that particular wall. So during our initial design process, we will get the drawings fairly close. They still require a review, especially if you're in a D, E, and F seismic zone. They're going to require a review, and the engineer will run a lateral analysis and essentially either add or subtract from what we've put in there to begin with.
Well, I think there's a couple of comments here that you can read. I think Long just was kind of explaining what was going on there, but I think that's it for our question assortment. Fantastic questions, great group, great insight and whatnot.
Excellent.
Todd, let's wrap it up. I'll give you just a quick, or give you a moment here to call it good.
All right. Well, thank you everybody for attending. Like I said, the Q&A part is, I think, a really good part of the process. It allows us to kind of answer some of those questions that we didn't get to. And feel free to contact myself or your local rep for where you're at, and we can answer any more questions or help you out on your specific project.
If you're looking for contact information, go to premiersips.com. There you'll find tons of information, case studies, all tech docs, all kinds of great information. That's where you want to start. And then if you're looking for Todd's email address or other contacts in your area, just go to the contact representative page. There's great people, great contacts information, tons of experience that you're going to want to follow up with. So, all right, Todd and everybody else, thanks a lot for joining us today, and we appreciate it, and take care. We'll see you next time.